Good afternoon to all. Afternoon. Sir, Sir Kathiran, sir. Good afternoon, sir.
Sir.
Sir,
Good afternoon.
sir,
Okay.
will you please come on live, sir? Video mode.
Yeah.
Yes, sir. It's came, sir. Thank you, sir.
Welcome. Shall we start the session, sir?
Yes, sir. Just 2 minutes. I will give you a little intro about you, sir. Right, sir.
Okay, thank
2
you.
minutes. Very good afternoon to all, and welcome to the ICT sponsored 2-day national workshop, national conference on electrical vehicle charging infrastructure, which is conducted by the Department of EEE in association with the ICT on May 9th and 10th, 2022. And welcome you all for the post-lunch session of day 1. And myself, Y. Praveen Kumar Reddy, working as assistant professor in Department of EEE CBIT. So it gives an immense pleasure for me to introduce our post-lunch session day 1 conference judge, Dr. K. Kathiravan, sir. So thank you, sir, for accepting our request. And sir has completed undergraduate in 2006 from the Department of EEE and completed master's degree in the specialization of power system engineering in the year 2011. Then sir has received a PhD degree award from the Department of EEE, Anna University, Chennai. Sir is working as associate professor and the head of the department in Theni Kamawar Sangam College of Technology, Theni, which is in Tamil Nadu now. And sir is doing service since 2012 in Theni Kamawar Sangam College of Technology. And coming for his contributions, sir has published 2 research papers in the reputed journals, and sir has organized various seminars and conducted workshops for UG students as well as for PG students. And the areas of field which are interested are power system restructuring, voltage stability, power system optimization, reactive power pricing and management, and concepts like FACS and smart grid. So thank you, sir, despite your hectic schedule, for accepting our request and associating with us for this post-lunch session as a chief judge for this conference. Thank you, sir. With your permission, sir, shall we start the session, sir?
Thank you, sir. Thank you very much. Okay, shall we start our session, sir? Okay.
Yes, sir. Yes. So, Monica, so connect for Monica. Thank you, sir.
Hello, sir.
Yes, ma'am.
Monica, you can carry on.
Yes, sir. Sir, is it visible my screen? Hello?
Screen is visible only. Just you make it full mode.
Okay, sir. Good evening to all. And my name is T. Monica, and my teammates are Bani Sahitya and Sai Deepika. And my topic is model of EV battery and charger.
Sorry to interrupt you, Nana.
Okay, sir.
Maximize the screen, Nana.
Okay.
Full screen. Put your presentation on full screen. Okay. Now carry on.
Yes, sir. My topic is model of EV battery and charger, sir. And at present world situation, as we are using a lot of petroleum resources for our transportation purpose, and in result which results in global warming and fuel. Fuel is almost to exist, and uh, which releases more greenhouse gases and which are harmful to entire world. Hence we are going for alternative ways, and these alternative ways are electrical vehicles. And now we are going for electrical vehicles which are common targets to overcome these serious problems. And car as a product of modern social industry, we are going for the electric vehicles. Electric vehicles are today's zero emission vehicular technology, and these are considered as a future for automotive industry, sir. And then therefore we are going for electrical vehicles. And in electrical vehicles, the battery model and charger model plays a very key role to improve the efficiency of electric vehicles. We need to select the battery model and charger model very effectively. And while coming to battery model of electric vehicle, there are three types of battery models. And uh, uh, our electrical vehicle performance is mostly influenced by the battery performance, and temperature and operating conditions, etc. And in these battery model of electric vehicles, there are three models: and Thevenin equivalent circuit model, and improved Thevenin equivalent circuit model, and PNGV model. And in these three models, Thevenin equivalent model, with battery working conditions and internal state charging, Thevenin equivalent circuit parameters don't change. So the accuracy of electric vehicle is too poor, sir. So we introduce the improved Thevenin equivalent circuit. And when we come to PNGV model, PNGV model. PNGV model is PNGV stands for Partnership for a New Generation of Vehicles, and PNGV model. This is when compared with the other two models, PNGV model has more advantages. And when we come to converters, etc., and the main working principle of this charging machine is, firstly, we inputting the three-phase alternating current to rectifying circuit, and through filter circuits we provide the direct current for high frequency DC to DC power transfer circuits. And finally the output of power transfer circuits goes to through the filter circuits to charge the vehicle battery. And in charger models, there are three charger models, sir. These are charger model of 6 pulse commutator, charger model of 12 pulse commutator, and the charger model of pulse width modulation commutator. And when we come across the charger model of 6 pulse commutator, in this process output voltage and current keep on changing. When we consider it in very short time, that is when we consider short period of time, that is ds, the output current and voltage is constant. uh, so to non-linear resistor or is used to simulate the input impedance of high frequency power transfer. Hence, 6 pulse uncontrolled rectifier charger changes the alternating current to direct current. Next, when we come across the charger model of a 12 pulse commutator, these in this 12 pulse commutator, rectifier is composed of 12 diodes. So this is called as a 12 pulse rectifier. The circuit is divided into parallel and series sections, and but when a rectifier is applied to charger given to the charger, we need to control the voltage of the rectifier, and this side, so we use uh, to so we use three phase transformer winding, three phase winding transformer. Uh, Next, while we come across the charger model of a pulse width commutator, uh, this is the most when we compare the previous models, these has more advantages, and the conventional rectifier part often uses uncontrolled diodes and IGBTs, etc., and which will inject the much resonant wave into grid, bringing pollution to grid. As a kind of device connecting power grid and power transfer devices, electric car chargers rectification devices uses PEWM technology. The main purpose is to achieve the control of input power factor in the rectifier, and the key is to control the grid current. Here, the pulse width modulation rectifier charging machine, we use three-phase voltage source PWM commutator, and it consists of IGBTs and diodes. And by using PWM rectification charger, we can control current on the grid side, and by controlling the voltage of pulse width modulation rectifier on the alternating side. And on other side, the current on the grid side can also controlled directly by closing the closed loop controlling strategy. The main role of here, we use the inductance in at alternating side. The main role of inductance is to isolate the voltage on the grid side and filter out the pulse width modulation rectifier's harmonic current. And my conclusion is, at present, most of the world is looking to up to electrical vehicles, and at present, vehicle to grid concept is on the rise. And in America, this is mostly utilizing, sir. V2G is a relationship between electric vehicles and power grid. V2G bidirectional charging and discharging device. We are using based on pulse width modulation, uh, that can realize the energy interaction between power grid and electric vehicle. This is essential for this vehicle to grid concept simulation. And in case of battery model, PNGV model has more advantages when compared with the previous two models, that is Thevenin equivalent circuit and improved Thevenin equivalent circuit, sir. So PNGV is a model recommended for the battery model to improve the efficiency of the electric vehicles. Thank you, sir. Hello.
Okay. Okay. Monica,
Yes,
from the grid side, you are using a rectifier, na? Right?
Yes, sir.
So the rectifier is uncontrolled rectifier or controlled rectifiers?
Uncontrolled.
Okay, go to the slide of your rectifier section. Next. Next. What is this? Go back. What is this?
12 pulse commutator.
This is commutator. There is a rectifier or else what this one?
Yeah.
This whether it is a rectifier or bridges. This is one. This one is rectifier or what? This one is controlled rectifier, uncontrolled rectifier. It's audible.
Yes, sir. Yes, sir. These are controlled rectifiers.
This is controlled rectifier, but you are implementing that. You are telling that you are uncontrolled rectifier you are using, right? Telling just before you told me that you are using uncontrolled rectifiers. So uncontrolled rectifier means only diodes only there. Here you are using diodes or the thyristors in this diagram.
Diodes, sir.
This is diode symbol or thyristor symbol.
Thyristor, sir.
Thyristor means it's coming under controlled rectifier, right?
Yes, sir. Yes, sir.
Right. Okay. Next one. Go to your slide. Heading slide. You are telling that model of EV battery and a charger, right?
Yes, sir.
Okay. EV battery and a charger. So this is you are discussing this point from vehicle side or a charging station side.
Charging station.
Charging station side, right?
Yes, sir.
Charging station side means there is a dual control you have to know, na?
Sorry, sir. I'm not aware of that.
Okay. 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 Next. Okay. Next.
Okay. Any more questions from the participants? I request participants to ask some questions. So any questions? Okay. So with your permission, we'll move to the next presentation, sir. Thank you.
Yeah,
Thank you so
yeah,
much,
go.
Monica and company.
Thank you, sir.
So now I request Varun Kumar and company, Varun Kumar and team to join the session. Nana.
Yeah, hello, sir.
Monica? Monica? So are you ready, Varun and team?
Yes, sir.
Please share your screen, Nana. Now, Nana. Now, put the presentation on full screen. Varun.
Yes, sir. Is that it is visible?
It is visible, but you have to put this put your presentation on full screen. Press Shift F5.
Yes, sir. Just a second.
Any issues, Varun?
Just a second, sir. So it is visible.
Yeah, it is. It is. So start your presentation.
Very good afternoon to everyone. This is Abdul from third EEE BTech. So my paper presentation PPT was different types of wireless electrical vehicle charging methods.
So here our teammates Varun Kumar and Sai Sudesh. So this is the content, the abstract history, introduction, what is wireless charging, basic operations types, operation techniques, battery, advantage, disadvantage, conclusion. So firstly abstract. Now we all know that day by day the pollution was increased by using one of the cause was the vehicles. The vehicles are using the fossil fuels like diesel and petrol, which has emissions and release the CO2 gases, which is harmful to the nature. To avoid this problem, we have uh, implement one EV vehicles, that is electrical vehicles. These are run by using the electricity. So here we are using the basic based on the principle of magnetic field based system, like basic principle of working principle of transformer. So this is the structure of wireless charging of EV. We have seen here the two coils, that are receiver side and transmitter side, and one two compensated networks and converters. Next, introduction. We are discussing about the electrical vehicle charging methods. They are basically charging methods are two types. One are wired and another was wireless. Wired means we all know that when the vehicle is parked, we are ported that the wire to the vehicle, then it will charge. It will take some time. But in wireless charging, we will able to charge while parking or while running. The cables were built underground on the roads. So this is the introduction. The history. We all thankful the great scientist Nikola Tesla. He is the one of the best scientists, and he invents a lot of inventions. The one of the invention was the Tesla coil, which was invented in 1891. And not only in Tesla coil, he also invented a uh, high high energy bridge that was world class in 1901. That was scrap on July 4th, 1917. So this is about the history. Though he is the Tesla and is working. So okay, what is wireless charging? Wireless charging uses electromagnetic field to transfer the energy between two objects through magnetic induction. Why not wire? We all know that many, as per studies, most electrical energy was transferred through the wires only. Most of energies losses during using the wires average above the 30%. In India, it exceeds in 40%. So in basic principle, this wireless charging basic principle was the basic principle of working transformer, which transfers the energy from one coil to another coil by use of for we giving the 220 volt 50 hertz AC supply, which are converted into high frequency alternator, which gives to the transmitter, which are available in the underground, that transfers that produce the magnetic field. Then it cuts on the receiver coils. That field cuts on the receiver coils on the through the air. Then alternate current will produce in the receiver coil also. That alternate current is in AC, that will convert into the DC and gives to the battery. Then will battery will charge. So the main topic, the wireless charging methods. There are two types: wireless charging, dynamic wireless charging. As we know, as a static means when the vehicle is stationary, which cannot move. When you are stationary, then the contact between the bottom of the car and the underground, the transmitter and the receiver will works and transfers the energy. So that's all for static. So we have see here the static about charging. This is the vehicle, and the downwards are placing the coil, receiver coil, and the underground there is a transmitter coil. Then transfers the energy. Then the receiver coil to connected to the battery. The charger will run. Sorry, charge. So that's the second one is a dynamic wireless charging. This dynamic wireless subdivided into two types: long track and segment track. Long tracks means which has underground long way. This can which the vehicle also charged while running condition. And the second one is segment track. We all know the in any roadways, we know there are two ways, left side and right side. We can mostly prefer that long tracks only. The segment track, when we are want to charge the battery, then we will shift to move to the right, and there specific place is there for charging. We can place the car, and then we charge will battery will charge. So dynamic can use both stationary and running condition for charge the battery. So operating techniques. These are based operating techniques classified into four types. Capacitive wireless charging, permanent magnetic gear wireless charging system, resonant inductive wireless charging system, and inductive wireless charging. At present, mostly used or most efficient one is inductive wireless charging system. So this is the picture of capacitive wire charging system. So the capacitive charging system, in basically the coils which are used, two coils are magnetic or capacitors. But here we use the capacitor plates on the transmitter and the receiver side. Between the receiver side, when we are want to charge, then we perfectly matched the energy will transferred from transmitter to receiver. The power factor correction circuit can be improve the efficiency and maintain the voltage level and reduce the power transmission losses. The receiver voltage on the receiver side converted into the direct current to provide a rectifier and filter circuit for the battery through a BMS. The frequency, voltage, the size of the blocking capacitor, and air gap between transmitter and receiver will affect the energy emitted. The operating frequency range is nearly 100 to 600 kilohertz. So the next one is permanent magnetic gear wireless charging. This is very simple. Instead of the capacitive plates, we are placing a armature winding which are consists of magnetic coils inside. The windings are placed in the receiver side and transmitter side. When we going alternating current to the transmitter, when it rotates and create a flux magnetic field, and which cuts the receiver side through the air, then the alternating current AC output appears in the receiver side, and then this AC output will convert in the DC and gives to and this DC output will charge the battery. The third one is resonant inductive wireless charging. It has this wants the additional compensator network to protect, and this here we are using the coils in a receiver side and the transmitter side. By this coil, the energy will transferred from the transmitter to receiver. So next also inductive wireless charging system. This is most important and very useful method. Basic principle of this inductive wireless charging is Faraday's law. Inductions wireless energy transmission is achieved by mutual induction. Magnetic field between the transmitter coil and receiver coil is produced. The AC power is applied to the transmitter. The AC magnetic field will flow through the receiver, and the coil and this magnetic field move the electrons in the receiver coil and produce AC output. The AC output is rectified and filtered to charge the energy stored system of the vehicle. So this is the structure of the inductive wireless charging. So the advantages: 80% reduce the operating cost than the equivalent gas power vehicles. Pollution free. As per now, we are not using any fuel to causes the pollution. The number of EVs will charge at a time. At a time, we will charge many EVs electrically safe, because we are using the underground cables. It's somewhat safe than the wired methods. Charging is convenient. Okay, charging also conveniently we will charge. Low maintenance cost. Law of power is low power losses. zero recharge time and unlimited range. And as disadvantage, okay, the main disadvantage is instantly cost is very high. By using the underground cables, the cost is very high for the any but any transmission lines, sorry, underground cables. Working area is limited. This will only use in cities and towns, not in villages. Currently, the speed of limited is 40 miles per hour. Complex design is very complex. Construction of wireless charging road is required. Yes, battery. We all know the engine is the heart of the vehicles, but similarly in heavy vehicles, the another heart is battery. The most of the vehicles are nowadays we are using lithium ion batteries to run the vehicles. But my suggestion or idea was to we have to check about another battery, that was the sodium ion battery, because lithium and sodium are the same neighbor elements in a periodic table, which has the similar properties. The lithium ion has lithium has less sustainability than the sodium ion. Then and also lithium ion was decreasing. Lithium ion elements were decreasing day by day. But sodium ion is cheaply cost, and it was plenty available to use. It is non-flammable, and sodium ion is non-flammable, and say it is very safe to use. Compared to lithium ion, sodium ion can produce the high electrolytes. Yeah, okay, some of advantages by using the sodium ion battery. Safety, it is gives more safety than the lithium ion battery. Availability and affordable. Available is plenty of sodium was available in our nature, and light in weight. The weight is light. Fast charging than compared to the lithium ion battery. Less cost compared to lithium ion. Lithium, the sodium is less cost and plenty to use. Non-flammable. The sodium ion was non-flammable than the lithium ion. Lithium ion is flammable, high efficiency than the lithium ion battery. So my idea and that was use a sodium ion battery to run a vehicle. Okay, that's the conclusion. My conclusion was that wireless charging is more is a natural step in the innovations of electrical vehicles. Not only for the fastest, we have to convert in EVs, because of to reduce the pollutions which are caused by the vehicles. We have to use the EVs, electric vehicles. We have to chargings are many types, but wireless charging is more efficient than the wired charging. So this was my conclusion. So thank you, sir. Thank you very much for giving this opportunity.
Good afternoon, Abdul.
Good afternoon, sir.
Have you done any model regarding this one, or simply you are telling the concept only?
Sir, I had read one article about
Okay.
the sodium and battery. This
Okay.
it is not in implemented. Yeah, that was in searching. I mean, experimental only. In future, it may be sodium ion battery will use bigger than the lithium ion battery, because of lithium elements were reducing, sir. That's why we are using the sodium. It is plenty in our atmosphere, and it is a cheaper cost than the lithium. So I can choose the sodium ion battery, sir.
Okay. Okay. Here you are telling a concept regarding that one. That's all, simply, right?
Okay.
You are not
Yes, sir.
made any model or done any simulations regarding this one.
Yes, sir. I'm not ready any model. I just is
Presentation
telling
of
simply presentation.
concept.
Yes, sir. Yes, sir.
Okay. 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 Okay, that means I just want to ask only one question: whether an inductor carries a DC supply?
Sir?
Whether an inductor carries a DC supply?
No, sir.
Then how the possible?
Conversion, sir. We can convert by using rectifier AC to DC.
Okay.
Then
AC to DC means that grid side. Okay, from the grid to the coil. Okay.
Okay.
Then
Sir.
after that.
After we are using additional compensated network, sir.
Okay.
And then after we are using the rectifier to convert the AC to DC, then it carries to the battery, sir, and the battery will charge.
Again the AC to DC again you convert, right?
Yes, sir.
AC to DC means what is that one?
Rectifier.
What type of power electronic controller is that? AC to DC rectifier, right? There is any DC to AC rectifier is DC to AC controller is there in your model?
In my model.
Go to the Tesla page. Showing the Tesla pages, I think.
Go back to the page, Nana. Go back to the slide.
Go back to the Tesla pages. Yeah.
Yes, sir. This is a DC to DC.
See that here you are using AC to DC and DC to DC you are telling, right?
Yes,
DC
sir.
to DC means this is coming under what type of power electronic controller? Basically, there is 4 types of controllers are there. Here, AC to DC means it's a rectifier. If it DC to DC means it is coming under what type of power controller?
Converter, sir.
What type of converter?
Uh,
The 4 types will be there. One AC to DC means rectifier. Here DC to DC means what? What type of controller is this one?
Sir, I think chopper, sir.
Chopper is right. Okay, fine. Okay,
Yes, sir.
now you're telling that go to that slide number coil, induction coil. Go to the induction section. Next to 2 pages. Wait. Go back. Go back. One step back. One slide back again. See this. So AC side power switches are there, right?
Sir.
Not this one. Next one. Next switch. Next one. See this AC side. There is a power switches are there, na? Right?
Yes, sir. Yes, sir.
The power switches are given to the transmitter, right?
Yes, sir.
And then the transmitter transfers to receiver side. Then what
Yes,
is
sir.
the gap between the transmitter and receiver?
Sir, can you repeat again, sir?
The gap between the transmitter and receiver, how much distance it will take?
Sir, I didn't have much knowledge, sir. I said that through air it will transfer the energy, sir.
Yeah, it will transfer, but distance is very important, na? Because if the air can transmit more amount of capacity of that electricity means we can easily use that air medium itself. But it is
Yes,
how
sir.
it is possible here. The gap, how much distance if it is cover means, if we have a clear idea in that means we can easily implement that. Otherwise, it is less possible only, na? So far, I'm
Sir.
asking this one. Yeah.
Okay,
Then
sir.
you are telling that one frequency. Go back. Next slide. Go to next. Next slide. See this. Go one slide. Step 1. Slide 1. I think wireless. This is RIWC. That tell the 10 to 150 kilohertz. You are putting that, right?
Yes, sir.
This is the frequency of that what?
Frequency which are applying to the transmitter, sir.
You're applying transmitter or the transmitter generate the frequency?
Transmitter will generate, sir, by using by we are giving the alternate current to the transmitter. It will generate 10 to 150 hertz, sir.
Okay, 10 means how much distance it will cover? 150 means how much it means? There is surely there is a distance because these kilohertz, basically these frequencies only determine the time quantity of the flow of the signal. Have you ever have that?
No, sir. Sorry.
Okay, fine. So this frequency related with the frequency, how the distance will be maintained here? That's my question. That's all.
Oh, distance between the transmitter to receiver, sir.
Yes.
Oh, it will approximately 10 meters, sir.
10 meters. 10 meters means you know that. One meter means
sorry,
100
sir.
centimeter.
Sorry,
10
sir.
meter means
10 to 30 centimeters, sir.
10 to 30 centimeter. That is 1 feet. You are telling that, right?
Oh, yes, sir.
Actually, it is for a low head type of vehicle. It is better. Okay, so if
Yes,
you
sir.
increasing the frequency, it will affect the frequency will be cross over the car metal body, right?
Yes, sir.
That also induce some disturbance in that vehicle, na? Right?
Yes, sir.
Because the base body of the vehicle will be a metal only.
Sir.
The be said. Then what type of this is suitable for all electrical vehicles type base body, or any special type can use for here?
All type, it will useful for all types, sir.
All type means it is give impact on that mental body, na? That frequency will impact on mental body, na? Right? Because it will transfer the frequency. It will hits that body, means it will injure that in person who are inside that vehicle, right?
Yes, sir.
Then how you will prefer this one?
Mm, in future, it will modify like uh, EV vehicles, sir. That will not damage.
Actually, Abdul, like
Sir.
the already a research has already done in this area, and
Yes, sir.
you go and search in a YouTube video regarding this work. Already a person will be successfully completed this part. Okay, for a few distance it will designed. So if you go the whether best you go and search that, you get in more idea in that, because right.
Okay, sir. Okay, sir. Thank
Mm.
you, sir.
Okay, Abdul.
Thank you.
Thank
Thank
you.
you, sir.
Let's go for next slide.
Okay.
So, thank you.
Okay. Thank you, Abdul.
Thank you.
So with your permission, we'll go for the next presentation. I, any questions do a participant have to Abdul?
Sir.
Uh,
Oh, yes. Yeah, atmosphere. Then we also concentrate on the lithium levels, right? Lithium level ions will decreasing, and it is cost is very high. Then sodium and uh, and also lithium was flammable, and sodium was non-flammable. While using the lithium, the battery will heated more and dry up. Well, sodium will not flammable, right? It will never gives any disturbance than the lithium ion.
So, any more questions from the participants? All right, we'll move ahead. I'll ask Pravachan and team to present.
Thank you, sir.
Okay. Pravachan, are you there?
Yes, sir, I am there, sir.
Now, please unmute other devices if you have.
Yes, sir, definitely, sir.
Okay. Now, please mute, Nana. Mute other devices if you have, and share the screen. Any issues from your side, Pravachan? Pravachan? Any issues from your side? Or hello?
Sir, just 2 minutes I will share, sir.
Okay, we'll wait for 2 minutes. Meantime, I request other participants to get ready. Nikita and company. Nikita, are you online?
Yes, sir.
Okay, now get ready with your presentation, Nana. Pravachan. Mr. Pravachan? Pravachan. Okay, we'll go with Nikita's presentation now. Now start presenting, Nana. Nikita, go on with your presentation. Nikita?
I think they have mic issues, I think. While sharing that screen, I think.
Yes, sir. Might be. Now, soon after Nikita's presentation, next participant, you just get ready with your presentation, Nana. Nikita, you can. Nikita, are you there?
Yes, sir.
Please present your presentation. Yeah. Now start giving presentation, Nana.
Okay, sir. Good afternoon to everybody, sir. So thank you for giving this opportunity to introduce myself. So my name is Nikita. So I'm studying BTech third triple E in CBIT College. So our team members are D. Chandrika and D. Guru Nikshiptastri. And what is my topic is electric vehicle charging infrastructures in plug-in electric vehicles. There is to be abstract. So nowadays, one of the major problem is fuel consumption. So day by day, the prices of petrol and diesel are to be increasing. So due to the hike of petrol and diesel prices, most of the engineers, scientists, and researchers are doing researches and finding the alternative things for the fossil fuels. So one of the best alternating things for the fossil fuels is so using of electricity. By using of electricity, you should go for the electric vehicles, and also we should discuss so plug-in hybrid electric vehicles, and also which type of connectors are using. So what is the best alternative source for the plug-in hybrid electric vehicles? So this paper mainly focuses on the charging infrastructures required for the electric vehicles. So to transfer electric energy from the distribution grid to the vehicle battery. So this paper mainly useful for the fresher candidates who is looking forward to knowing the basics of electric vehicles. It means budding engineers only. So electric vehicles that are either partially or fully powered on electric power. So electric vehicles have low running cost as they are less moving parts. So maintaining cost, and also very eco-friendly in nature. So electric vehicles are also called as battery electric vehicles, having a battery that is charged by plugging only. So the vehicle is to charging equipment. So it ranges from 130 to 300 miles. So electric cars functions by plugging into the charge point. So and taking electricity from the grid. So they store the electricity in a rechargeable batteries. So that power an electric motors which turns the wheels. So electric vehicles accelerated faster than the traditional fuel engines. It means diesel or also petrol engines. So they feel lighter to drive. So next, so electric vehicle models. So here is to be used to what is the electric vehicles and in developing in nature. So we are using so so 1.2 to 3.3 kilowatt hours with a battery voltage of 48 to 72 volts. So and next we are going to 3.6 to 8 kilowatt hours with 48 to 60 volts. So in first generation of electric cars, so 21 kilowatt hours with 72 volts. And next generation of car, and here is to be so developing the electric cars. Here development what it so battery is to be developing. So
second generation of battery capacity is 30 to 80 kilowatt hours, and its battery voltage is 350 to 500 volts. So what is the history of electric vehicles? So in 1830s, the first electric carriage was built. So in 1837, so Robert David has built the first electric car in the world. So after 1819, so America also has has used the electric vehicles, and also mainly the history of electric vehicles is related to the development of battery only. So in 1900s, so the electric vehicles were to be introduced, and William Morrison is also invented the electric vehicles. So in 2011, 16,000 electric vehicles were registered in North America. So a decade after, to 2021, so 735,000 electric vehicles are to be used in market, are to be introduced in our market. And a decade later, that it now, so today onwards, now 2022, 2 millions of electric vehicles are to be, so manufacturing are to be produced into the markets. So this is the history of electric vehicles. So here, sources of energy, consumptions, emission, which type, how many types of electric vehicles, and what are the sources to drive the vehicles means. So conventional, hybrid, plug-in hybrid. So here my topic is plug-in hybrid. So an electric vehicle, all electric. So here sources of energy of conventional means only fuel. So hybrid also, it to drive the vehicle by fuel only. So plug-in hybrid by fuel and charge by charging. All electric means the battery is to be charged by plugging only. So fuel consumption by conventional only, fuel consumption only. Hybrid, high amount of fuel consumption and low amount of battery charging. Plug-in hybrid means less amount of fuel consumption and high amount of battery charging. All electric means it should only charge the battery by the vehicle. So emissions. So conventional also have an emission, hybrid also emission. So plug-in hybrid also 0.5 to 0.25% of emission is there. So all electric also no emission. So why should we go for the no emission? So but why I'm considering plug-in hybrid means, so all electric vehicles is to be developing nature, not developed, but plug-in hybrid is to be developed. So many of the country has to be implemented successfully. So that's why I'm taking that plug-in hybrid electric vehicles. Next, so types of electric vehicles. There are 4 types of electric vehicles. So battery electric vehicles are also known as all electric vehicles. It means it should be charged by the battery itself only. So hybrid electric vehicles is also known as series hybrid or parallel. Series hybrid or parallel, combination of series parallel. Hybrid means it should be more consumption of fuel and less charging. Plug-in hybrid electric vehicle. So this is less amount of fuel consumption and large amount of battery charging. So fuel cell electric vehicles. So there are 4 types of electric vehicles. Next, components used in electric vehicles. So the main components used in electric vehicles means battery, motor, onboard charger, inverter, so drivetrain, so EPCU. So here batteries. So battery is also called as a traction battery. So it is a rechargeable. So it is used to give power to the electric motors of battery electric vehicles. Batteries used in electric vehicles are mainly lead acid, nickel metal hydride batteries, and also mostly preferred battery is the lithium ion battery. So we are all know battery is the heart of the electric vehicle. So next, motor. So it supplies power to the rotor vehicles. It is a DC or AC type. So AC motors are mainly preferred. So inverter. So drive time. So drive time, you are using the differentials in shafts and drive trains, drive shaft and differential shafts. For that purpose, we are using. So next, so plug-in electric vehicles. So we are all know. So plug-in hybrid electrical vehicles means, so we are using both fuel and battery. So by consumption of fuel, which stores the energy into the battery. So plug-in electric vehicle is any motor vehicle with rechargeable battery and battery pack that can be charged from the electrical grid. And also, so plug-in electric vehicle has several benefits compared to the conventional internal combustion engine vehicles. So plug-in hybrids provide, so most of the electric car, so when they are operating all modes, so through typically, so having shorter all electrical ranges, but have the auxiliary option of driving as a conventional hybrid vehicle. So when the battery is to be low, so using its internal combustion engines. So that is the plug-in electric vehicles. In North America, so each and every vehicle manufactured with the SAE J1772 connector is also called as J-plug, and level 1, level 2 connectors for 120 or 240 volts charging. So plug-in electric vehicles is also known as new energy vehicles. So plug-in electric vehicles is a subset of vehicles, so which includes the battery vehicles also. So this is plug-in electric vehicles. So these are 4 types of plug-in vehicles. So countries mainly used in, so the Tesla Model 3 ranked as the world top, selling highway capable plug-in electric cars in history. So this is the Tesla Model 3. So and is the Nissan Leaf and Chevrolet Volt, so and Toyota plug-in Prius. So these are all used in the world. So these are all the same configurations of plug-in hybrid vehicles. So next, so countries using plug-in electric vehicles means, so Mitsubishi Outlander PH plug-in electric vehicles in the world all time. So but selling plug-in hybrid with the global sales of around 3 lakhs units in Jan 2022. So in December 2021, China has the world's largest stock of high-range highway legal plug-in electric passengers with 7.84 million units. So Europe also with 5.6 million units. So plug-in cars and vans at the end of 2021 in US, America. So 2.32 plug-in cars is to be introduced. So in Germany, so 1 million plug-in vehicles are to be introduced on the roads. So which country has the highest market penetration in the world means Norway. So Norway has the highest using electric vehicles so today onwards also. So here we can see that the Tesla Model 3 is so using the 86.2% so penetration in entire worldwide. Tesla Model 3 also a type of configuration of plug-in hybrid electric vehicle. So why electrical cars is not popular in India? So due to the high cost or price. So lack of infrastructure both in public and private domains. So previously we have discussed plug-in hybrid electric vehicles. So why should not go for the all electric vehicles meet? So suppose we have to go for the long distances, so instead of there is no charging station, so that's why so many of members who are not willing to purchase that electric vehicle. So we can implement the infrastructures in public and private domains. It can be popular in India also. For that purpose I will electrical charging station with rooftop solar I will consider. So the electric vehicle charging stations with rooftop solar panel charge, it have low maintenance cost and also low running cost. Why low running cost? Because the electric vehicles are less moving parts, less moving particles to petrol and diesel vehicles. So here I'm told low maintenance cost. To arise with again we can arise one doubt. So why should we are using solar panels? Why should so we told low maintenance costs. So by comparing to the fuel and diesel vehicles, it have low maintenance cost. So electric vehicles are looking more attractive by using this rooftop solar panel charge, and also rooftop solar panel charges on electric vehicle or electric car. The simplest way to charge the car. So using rooftop solar panels is to plug the car into the public places. So during the day when the sun is shining. So charging an electric vehicle, so using rooftop solar is quite easy using a portable plug-in level chargers. So they have 2 type of level chargers. So level 1 charger is to use as a 5 kilowatts solar system, and level 2 charger at fuel during cloudy or bad conditions it can be activated. So this is where, so in this particular, so smart EV chargers also can help along with the charging connections. So next, using a smart by using of smart electric vehicle chargers, so only charging function is the best way to charge an electric vehicle. So your own rooftop solar. So level 1 is to be portable 10 amperes plug-in. So it's to be used in homes only. So level 2 is to be wall-mounted applications, 5 kilowatts to 22 kilovolts. So mainly we are focusing level 3 pointed because our main purpose is to develop the infrastructure in public and private domains. So for that purpose, roadside electric vehicle charging station from 50 kilowatts to up to 300 kilowatts is to be used. So so it can be implemented in India. It's of course. So New Delhi it will successfully implemented, and battery capacity, and in New Delhi it can be used battery storage capacity is equals to the 40 kilowatt hour, so which is stored approximately 16% of total daily solar energy. So 5 solar panels are most of the 5 are also using to charge the electric vehicle. 5 is too sufficient. So according to the US government, so the average American drives about 13,500 miles per year, or about 40 miles per year it can be used. So solar rooftop panel charging is a conventional source. It is free of cost by using this. And next, so types of connectors used in electric vehicles. So type 1 plus. Type 1 plug is a 5-pin design and type 2 plug is a 7-pin design. So type 1 has used single phase supply, but whereas the type 2 is used for single phase and 3-phase supply. So type 1 and type 2 used for the AC current, and type 3 is used for the type 3 is used for the DC current. So type 3 is mostly is used in 3-pin plug in India. So fastest type of charging. So in CCC, so combined charging system. So combination of type 1 and type 2 connectors to provide power up to 350 kilowatts. So next CHEDEMO. So combined charging network is expanding fast, greater than the CHEDEMO. It's the only way to go into the US for charging beyond 100 kilowatts. Next, so conclusion. So in order to reduce the usage of fossil fuels and to protect the environment, we are going to use the electric vehicles in future. And so what is my main conclude of electric vehicles mean? So the contribution making towards improving air quality in towns and cities. And next. So we will not stop until every car and the road is electric. So last but not the least, my quotation is, so don't go for the fuel vehicles. If you go for fuel vehicles, pollution will automatically follow you. So thank you for giving this wonderful opportunity. Thank you, sir.
Right, Nikita.
Yes, sir. Good afternoon, sir.
So you are telling that in electric PHEV, like in
Yes,
electrical
sir.
vehicle, they are using the machine motor na. Which type of motor they are using?
So based on applications, sir, asynchronous induction motors we are using, sir. Brushless asynchronous induction motor.
That is brushless asynchronous machine. Only
Yes,
asynchronous
sir.
machine. Especially any name, special name for that? Mainly, there are two types of machines are using in reality, what are that?
So BLDC, sir.
Okay. Second one.
So permanent excitation motors.
Switched reluctance machine. Okay.
Oh, yes, sir.
Okay. Go ahead. Okay. Next. Thank you.
Thank you, sir.
Any questions from the participants? Any questions from the participants?
So we are going for the conventional only, auntie. I mean, we are driving in long distances. So your solar energy only it will be available in any place. So that's why I'm taking that topic only particularly. It is a free of cost. So it will be implemented in our homes also. So that power supply we can use to charge the battery of electric vehicle. So we can terminate the fossil fuels. Main consideration is that. So we can go for the alternative methods also, but I can take that particular concept only.
I have a question from my side. Nikita.
Okay, sir. Please tell me, sir.
Uh,
Please
you
ask.
you you shown some of the plugin types, like type 1, type 2, and the combination of the two,
Yes,
where
sir.
you have stated like one of type 2 is for DC supply. I didn't
Ah,
get it.
so type 1 and type 2 is used for AC, but type 3 is used for DC, sir.
but,
Some rare cases it can be used as DC also, sir.
but there is
In
no
my
type.
knowledge, sir.
Will you please open the slide?
Yes, sir.
There are only two types, as I can see in the presentation: type 1 and type 2.
Yes, sir.
How about type 3? You said you're telling like type 3 type of plugin there.
Ah, yes, sir. It's my mistake only, sir. 3-pin plug, not type 3, sir.
Okay, okay. Type 2 is used for three-phase supply. You said.
Sir, yes, sir. It can be used both single phase and 3-phase supply, sir.
Three-phase supply, particularly DC. You said.
Yes, sir.
Okay. So which plug is nowadays we are using in India? Like that are
3-pin plug, sir.
charging stations that we have available in India.
3-pin plug mainly used in India, sir.
Fine. Second question, what I have is, what sort of software you're using to charge this vehicle? There are different means of charging, like CMOS charging, MPAS charging,
CMOS charging, sir.
CMOS charging. Okay, fine. Thank you so much. Any more questions from the? Thank you so much.
Thank you, sir.
Uh, so with your permission, I can go with the next presentee. So, Pravachan, are you online? Pravachan?
Yes, sir.
So are you ready to present?
Yes, sir. Yes.
Please share your screen, Nana.
Audible, sir.
Yes, it is, Nana. Please share your screen.
Yes, sir. The screen is visible or not, sir?
It is not showing, pa.
Yes, sir. Wait, sir. Wait. Now, sir.
Yes, it is.
Yes, sir. Very good evening to everyone.
Put the screen on. I mean, put the presentation on full screen.
Full screen. Full screen.
At the bottom, you have a screen like a slideshow. Just click on this slideshow icon, or else press Shift F5.
Yes, sir. Yes, sir. Now, okay, sir.
The screen is yet the same.
Network lag, sir. Sasikumar, sir. I think
Sir.
network lag is there. I think so. Only it is not showing.
Okay.
Now, shall I continue, sir?
Make it
Yeah.
full screen. Make it full screen. First, you click the enable editing. First you click the enable editing on top of that. Then you click that full screen. First, you click the enable editing on top of that presentation. AICT sponsored above that. Yeah. Just edit. Then you make it full screen.
Meanwhile, the next participant, Anuradha. Now get ready with your presentation.
window like wo. Look.
Now it's okay. Fine.
Start your presentation.
Oh, it's okay, sir.
Okay, carry on.
Okay, sir. Very good afternoon to everyone. Very good afternoon to everyone, sir.
Good afternoon. Carry on.
Myself Sudhir Kumar. My team members are Pravachan and Rahul, sir. So now I want to discussing about the electrical vehicle charging infrastructure. So why we have to use electrical vehicle means there are a lot of advantages are in electrical vehicles. The major benefit of electrical vehicles is that towards improving air quality in towns and cities. So with no tailpipe, fewer electric cars produce no carbon dioxide emissions when driving. So this reduces air pollution. So you want to get some advantages. So why why the top 5 reasons are there why we using electrical vehicles? The first reason is electrical vehicles save you money, sir. So you want to see in our country wherever you can go and you want to buy some car, compulsory it will be cheaper than the uh, gasoline engine vehicles are like a diesel engine or petrol engine. So these are the first advantages. And second advantages is we want to less maintenance cost, sir. So why means in gasoline engine there are some oil changers and spark plugs and tempting plates are like that, sir. So we want to every some time of period we want to exchange that oil and spark plugs, sir. So but in electrical vehicle there is no need, sir, for oiling the oil exchanges and spark plugs like that. So you want to compulsory you want to less increase you want to less maintain cost, sir. So that is the one type of reason. And the second one is you want to reducing the emissions, sir. Emissions. So in electrical vehicle the carbon dioxide is not released. Why means in electrical vehicle there is no any gasoline engine, so there is no any engine. Just you want to you want to place one motor, sir. So because of that motor only you want to run. So that is the one thing. And you want to in electrical vehicle the it will be first high starting start, sir. In with the starting only there will be some more speed you want to go. But in you want to go with some induction motors. In induction motor the starting torque is somewhat less. So in somewhat like in speed breakers in induction motors will be you want to pick up means it will take sometimes, sir. But in electrical vehicle within short time only we will pick up the speed. So that is the advantage of the electrical vehicle. Now I want to telling about the contents of this presentation. So first one is I want telling about the gallium nitride with a new device and synchronous electric motors and bidirectional converters. So and I want telling about the super capacitors and battery management system, active cell battery management system and active thermal management and the synchronous electric motors and using of the super capacitors and LED lights and etc, sir. Now I want to telling about the gallium nitride, sir. So it is a power semiconducting device. So it is advantages of the advantage and upgrade device, sir. So in olden days we want to use a silicon. So based on the silicon, gallium nitride is a very useful and a very fast switching device, sir. So in gallium nitride it will less in less time only you want to operate many switches and it will converted the voltage to the motor. So that is the advantage of the gallium nitride. It is the very fasting switching and this band gaps also very high. So that is the advantage of the gallium nitride.
and 1:30 we'll go for lunch session again.
Okay.
Thereby we'll start our afternoon session, sir. So by 3 or 2:30 we are going to end our sessions tomorrow also.
Okay. Afternoon session full of our own native college students, right? Full
Yes,
of
sir. Yes, sir. Few
Okay.
few are external papers, few are external and other than our college. A
Okay.
few are internal people, sir.
Tomorrow, sir?
Tomorrow morning we have around say 12 to 15 papers, sir. Okay. Thanks a lot
Okay.
again.
Thank you. Okay, bye.
So this is the end of our session for the first day schedule. We are going to close the session now. Probably the participants who did not receive a call today, so may have their presentations tomorrow. So get ready with your presentations for tomorrow. And the first session, the morning session will start at 10 a.m. Thank you so much.